Welcome. Today we'll be discussing section 4.1, angle difference formulas with sine and cosine. We'll finish up the video with tangent formulas of angle difference formulas for tangent. So for sine and cosine, looking at angle difference formulas. This is a powerful tool of being able to combine cosines and sines when multiplied together. And we'll see how. So cosine of alpha plus beta is equal to cosine of alpha times cosine of beta plus sine of alpha times sine of beta. Sorry, this is subtraction. Alpha minus beta is equal to cosine alpha cosine beta plus sine alpha sine beta. And sine of alpha minus beta is equal to sine of alpha times cosine of beta minus cosine of alpha times sine of beta. So something that may or may not be a trick to remember these formulas is that cosine is an even function, and so we get a positive sign in the middle, and then sine is an odd function, so we get a negative or subtracting in the middle. That rule is quickly broken with sums, as we'll see next, but with the memorization game, cosine, we're gonna have cosine cosine plus sine sine, and then sine is gonna be sine cosine minus cosine sine. So we also have the angle sum formulas. Now, these in a way are kind of just the same as the angle difference formulas. Because you could think of this as we're going to have cosine of alpha plus a negative beta. And when I view it in this kind of context, a negative beta here is just going to be positive. So we're still going to have cosine of alpha times cosine of beta. But then if I had a negative beta here, I could make it positive by taking the negative to the outside because sine is an odd function. So I have negative sine of alpha times sine of negative beta. Now I put negative beta here because it's negative, but if I take out this negative, I take out this negative, and now we have the angle sum formula. So you can think of this as just the angle difference formula, but with the negative beta. In a similar fashion, we'll have sine of alpha plus beta is equal to, and we'll have sine of alpha cosine of beta. Again, think that if we had this negative beta, then this would just turn into positive beta. And we're going to now add cosine of alpha sine of beta, because I can take the negative to the outside, making this negative turn into a positive. So with a memorization game, you can think of the angle difference formula, make this negative be alpha plus a negative beta, and now you have the angle sum formula just by following that through and simplifying. Similarly, sine of alpha plus negative beta, you take that change, walk it through the formula, and you'll get the angle sum formulas. So these will be your check on learning for this week, is to write these down verbatim, both angle difference formulas and angle sum formulas. We'll hit some examples, and then we'll go over the tangent version of this, which you can imagine that the tangent, we just take these, take one divided by the other, and we're going to get the tangent. So it's important, really, if you have the angle difference formula, you'll be able to get the sum, and you'll be able to get the tangents, sum, and difference. So let's start off with example 1. So we're going to have sine of 5 pi over 12 and cosine of 5 pi over 12. And using the angle sum and angle difference, we want to find the exact values of these. So what we can do is go 5 pi over 12. What exact values can we pull out of this that we wish it would be, because we know what cosine and sine of these values would be? Well, I would like to see a pi, like pi over 4 or a pi over 6, something like that. So let's, or like pi over 3. So let's try and make that happen. Well, we can split this into 3 pi plus 2 pi, because that would equal 5, divided by 12. And 3 pi over 12, well, that is pi over 4. And 2 pi over 12, that is pi over 6. So we have a sum here, so we can write down that sine of pi over 4 plus pi over 6 is equal to sine of pi over 4 times cosine of pi over 6. This is add cosine of pi over 4 times sine of pi over 6. And I know that sine of pi over 4, well, that is square root 2 over 2. Cosine of pi over 6, that is square root 3 over 2. So I'm going to times these together. I'm going to add cosine of pi over 4, that's square root 2 over 2. Sine of pi over 6, well, that is 1/2. So we put that all together, and we get sine of 5 pi over 12 is equal to, and we are going to have square root 6 over 4 plus square root 2 over 4. Let's put those together. And we have square root 6 plus square root 2 all over 4. This equals sine of 5 pi over 12. That's our answer. That's our answer for sine. Cosine will behave much the same way. So let's find that. Cosine of pi over 4 plus pi over 6. And we can put this through the sum formula for cosine, and we'll get our answer. I want to highlight that the sum formula is just the difference formula by making this be equal to cosine of pi over 4 minus a negative pi over 6. Again, if you did the sum formula with cosine, you would get the exact same answer, but I'm going to use a difference formula to showcase this fact. So when we take this, we follow through our angle difference formula, and we have cosine of pi over 4 times cosine of negative pi over 6. And we're going to add sine of pi over 4 times sine of negative pi over 6. And now we can evaluate that cosine of pi over 4 is square root 2 over 2. We're going to times that by cosine of negative pi over 6. Well, that will be square root 3 over 2 plus sine of pi over 4, that is square root 2 over 2, times sine of negative pi over 6, and we'll get negative 1/2. Simplifying this, we're going to get square root 6 minus square root 2 all over 4. That is cosine of 5 pi over 12. So again, showcasing that as long as we know the angle difference formula, we can find the angle sum formulas or solve it with the angle difference formula and not the sum formula. Okay. Let's see another example of this. So we want to find sine of some theta and cosine of some theta. We want to find the exact answer, and we have theta is equal to 5 pi over 6. So here we can write, okay, theta is equal, or you have 5 pi over 6. Well, that is equal to pi minus pi over 6. And so now I have, let's start off with sine again. Sine of 5 pi over 6 is equal to sine of pi minus pi over 6. And here we could think of this as also an add pi identity. But if we didn't catch that, we can then run it through the formula and we can have sine of pi, sine of pi over 6, sorry, negative pi over 6. We want to subtract cosine of pi. Oh, sorry, this is cosine. So sine of pi times cosine of negative pi over 6 minus cosine of pi times sine of negative pi over 6. And we'll see that sine of pi is 0, so this just zeroes out. Cosine of pi is 1, so we can ignore that because that's just 1. And sine of negative pi over 6, that is negative 1/2. But we have a negative out here, so we just get 1/2 as our answer. Notice we could have seen that sine of pi plus pi over 6 is the same as sine of pi over 6, which gets us the same answer. But this is also showcase the power of the identities. We would have saved ourselves some work had we caught that, or if we didn't catch that, I should say. So cosine of pi minus pi over 6. We can run through the difference formula on this, and we have cosine of pi times cosine of pi over 6, right, negative pi over 6, plus, sorry, this is actual pi over 6, plus, and we'll get sine of pi times sine of pi over 6, which we have sine of pi going to 0, so that takes out this. Cosine of pi going to negative 1. Oh, I'm sorry, I made an error. This should have been just positive. This would have been negative 1 canceling out with that. I'm sorry, I made a mistake there. But all works out in wash. So here, this is negative 1 times cosine of pi over 6 plus this is all 0, which then cosine of pi over 6 is square root 3 over 2, and we attach a negative. So this is equal to cosine of 5 pi over 6. That's if we didn't recognize what we had there. This is another way of finding it. Yeah, again, to reiterate this mistake here, this should have been negative. This should have been positive. I didn't catch it with this one because it just zeroed out. And then this one, this became negative, so then the negative dropped down here. So we had positive and sine of positive. So I inadvertently used the sum formulas, but that's okay. So what can we do with this? We can make an expression. We can turn different expressions into the addition and subtraction of sines and cosines. Because we'd rather have sines and cosines be simplified and concise rather than like a sprawling mess. So we can have f of x equals a cosine of kx plus b sine of kx. So if we have this, we can start using these sums and difference formulas to start to combine these into a single equation. So we're going to have theta equal the sine of b times cosine inverse of a over square root of a squared plus b squared. In other words, we're taking this function and we're going to try and find theta, and we're going to try to write this function in terms of x minus this theta here. We're trying to combine these two. So by having the sine of b, so if this is positive, then this is positive, this is negative, this is negative. Cosine inverse, we're going to take a divided by the magnitude, or you can think of the distance of a and b, so square root of a squared plus b squared. Then we're going to say that f of x is equal to square root of a squared plus b squared times the cosine of kx minus theta. So this equation, we can rewrite it as a single equation of cosine given this theta. So let's see an example of this. So example, let f of x be equal to 3 cosine of 5x minus 2 sine of 5x. And we want to find all maximum points. So in order to do this, this will be hard to graph both the sine and the cosine wave together. We instead can write them as a singular wave. And then from here, we can find all the peaks of this distance, so we have an amplitude, and then from here we can find where each peak where cosine is equal to 1, essentially. So let's first start with that. Let's start with a theta. So theta is equal to, we want the sine of b. So here we could think of this as 3 cosine of 5x plus -2 times sine of 5x. So we have the sine of -2. So we're going to have theta is equal to negative cosine inverse of our a, which is 3, over the square root of our a, which is 3 squared, plus our b, which is -2 squared. And we get negative cosine inverse of 3 over square root 13, which is approximately equal to 0.5880 radians. So now we can write f of x is equal to, and we get square root 13, because we have a squared plus b squared here, taking a square root of it. And that's what we found here. And then we're going to have cosine of 5x minus 0.5880. Now, the 0 is still written there because I'm writing it in terms of 4 significant figures, and that shows that when I rounded, I got a 0 there. So that's signifying that I rounded. I do not have an exact answer. So now I want to find when this is maximum. So in other words, when this cosine of this angle equals 1, how can we determine that? Well, when it equals 1, we're going to have 13. So we know the maximum is going to be square root 13. So we're going to have max at f of x equaling square root 13. So we have square root 13 equals square root 13 cosine of 5x minus 0.5880. So in other words, that's 1 is equal to cosine of 5x minus 0.5880. Take cosine inverse of both sides, and we get cosine inverse of 1 plus 2 pi n is equal to 5x minus 0.5880. Cosine of 1 is 0, so it just kind of goes away. So we then we want to solve for x here. So we're going to add this 0.588 to the other side and divide by 5. So we get x is equal to 2/5 pi n plus 0.1176. So this n again is an integer, so we have a one instance of a peak, and then here is the period in which we hit the next peak of the cosine wave. So we're not quite done yet because we want to find all the points. We know the y value is square root 13. We now have all of the x values, so we can write this as 0.4 pi n plus 0.1176, comma, square root 13, close parentheses. There's all the points that are maximums. 0.4 is just 2/5. I wrote it as a decimal because I'm adding another decimal here. So, in summary for this exercise, we started with the function. We rewrote it so we had b, whether we could tell if it's positive or negative. We then used the formula to find our theta. We then plugged it into an equivalent equation for f of x. And this equivalent equation, we now know that the peak is at square root 13. So we found whenever cosine is equal to 1. And going through those calculations, we were able to obtain all the x values in which we had a peak. So we have all of our x values. We have our y value of square root 13, which then that collection is all the points of maximum value of the function. So another example is if we want to solve f of x instead of finding the maximum or minimum points. So now we're going to have an example where we want to find all the solutions to 2 cosine of 2x plus 2 sine of 2x is equal to 1. So in other words, we're having an f of x here, but we're interested of when f of x is equal to 1. So to highlight this, let's rewrite this one as f of x. We want to find all solutions. Find all solutions when f of x equals 1. This is an alternative way of writing this question. So what do? Well, let's first write this in terms of a function in terms of cosine and just that. So theta is equal to, we want the sine of our b, which is positive 2, so we're going to have positive cosine inverse of a 2 over square root. We're going to have 2 squared plus 2 squared, so 2 squared plus 2 squared, which we then can simplify this to cosine inverse of 2 over square root 8, which is cosine inverse of 1 over square root 2, which is square root 2 over 2. And that gets us pi over 4. So now, when we take pi over 4, we have f of x is equal to, and we're going to have our distance, which is square root 8. So this bottom value times cosine of 2x minus pi over 4. We want to find when this equals 1. So we're going to set 1 equal to square root 8 cosine of 2x minus pi over 4. We're going to divide by square root of 8. And then we're going to take the cosine inverse. So look over here, we're going to have 1 over square root 8 equals cosine of 2x minus pi over 4. Take the cosine inverse, so we have cosine inverse of 1 over square root 8. We're going to add 2 pi n to the plus or minus of whatever this equation is. Now, something to note is when we took cosine inverse here, we got the principal answer from the restricted domain of cosine, which again is from 0 to pi, inclusive of 0, exclusive of pi. Here, we're looking for all possible, so we're interested in the repetition, which then we have 2 possible values of a positive or a negative, and then a repetition of a period of 2 pi n. Well, that period is adjusted because we're going to have this equal to 2x minus pi over 4. So we now can take this value, add this value across, then divide by 2. So in total, we're going to have plus or minus cosine inverse of square root 8/8. Again, it doesn't matter whether you rationalize the denominator or not, either answer is acceptable. I'm just showing you because it's good to know. We're going to add pi/4, add 2 pi n, and this is equal to 2x. Divide by 2, and we're going to say that x is equal to plus or minus 1/2 cosine inverse of square root 8/8 plus pi/8 plus pi n. And this is my answer. Notice I have two sets of answers. I have the positive version of this plus the period, and then the negative version of just this cosine inverse, and then plus the period. So that accounts for both times that you'd hit it while you're drawing your sine wave. Now, this is fine for my answer because my question was find all solutions to this statement, sine f of x equaling 1. So I just needed to find the x's, where before I needed to find the maximum points, not just what x gets us the maximum point. So it's important to know what kind of answer you are required to give, and it can be subtle at times. So the last topic of the video will be the tangent formulas. And as you could probably guess, it's just an amalgamation of the sine and cosine formulas. So tangent formulas. We have tangents of alpha plus beta, and we can look at sine of alpha plus beta and go, okay, so in the numerator, I'm going to have sine of alpha cosine of beta plus cosine of alpha sine of beta. And in the denominator, that's equivalent to cosine of alpha plus beta. So I look at my formula and I get cosine of alpha times cosine of beta minus sine of alpha times sine of beta. Now, we can take this and we can start running through different trig identities, and we'll eventually get to tangents of alpha plus tangents of beta divided by 1 minus tangent of alpha times tangents of beta. Again, how will we go from here to here? We'll just take the top and bottom, divide by cosine alpha. Cancel here, and then we're left with sine of alpha over cosine of alpha, giving us tangent of alpha. Now divide the top and bottom by cosine of beta, and again, this will now just be 1. Here we get tangent beta, this is gone. Here, this goes away. We already have tangent of alpha. And then of course here, we just get our tangents. So it's, again, angle difference formula. generates everything. Let's look at tangent of alpha minus beta. We can take our steps and write down the angle difference formula, and we can do the same thing, but eventually we'll work it out to tangent of alpha plus minus tangents of beta all over 1 plus tangents of alpha times tangents of beta. And you can guess it is the exact same thing that's being done. Let's take a look at an example real quick. We want to find tangent of tangent inverse of 10 plus tangent inverse of 7. We want to find what this is equal to. So what we could do is, this is a value, this is a value. We could write this as tangent, or have this be equal to. This is a sum, so let's look at our sum formula that's here. It's equal to tangent of our alpha, which is tangent inverse of 10, plus tangent of tangent inverse 7, all over our denominator, 1 minus tangent of tangent inverse of 10 times tangent of tangent inverse of 7. And now we can simply go tangent inverse of 10, that's 10, plus tangent inverse 7, that's 7, all over 1 minus tangent inverse 10 is 10, tangent inverse of 7 is 7. So we get 17 divided by 1 minus 70, which is negative 69, which is equal to negative 17 over 69. And that is our answer. This concludes the video. Thank you for watching, and have a great day.